Hey everyone, Tommy Thomas here with Leaseworth Robotics. We're really excited to be making our first video here. This is a new direction for the team. We're starting to make videos of our build process, of everything from designing the robot, the concepts behind it, through the CAD tool paths, up through machining, assembly, videos of it in action, and then a post-mortem afterwards to show you what worked, what didn't work, what went wrong, what we do different next time, and then you'll get to see the next revision of the robots. So I wanted to start off today with our first robot. It's going to be a Fairyweight 150 gram. That's the smallest class that's fought in the US right now. There are local competitions here in Southern California where we're based, so it's a great place to start, and there are venues all across the US that do it, that fight these robots, so it's a great place to start. For our first design, we've decided to go for a full body spinner. We've had previous designs, making wedges, making vertical spinners, horizontal spinners, and heavier weight classes, but we really wanted to push ourselves to the limit here and do a full body spinner. So just to give you guys a quick overview of what a full body spinner is, here are some horizontal spinners, they're called, in the Robots manual. The Robots manual is a great resource. It's the Bible of combat robots. It has everything from overviews of the different types of robots here. It has this chart here that shows you basically a rammer is going to be more effective than a spear bot. If it's fighting a spear bot, but against a wedge, it's going to lose. So we're here, right here, in the horizontal spinner category. They don't really break it out much more. This is an overhead bar spinner, but we'll be making something that looks more like Megabyte here. This is a 250-pound robot from Team Robotic Death Company, and it's a full body spinner. It's a full shell that spins around, protecting all the mechanism inside, giving you a lot of energy storage so that you can deliver really powerful hits to your enemy. So we're right here in the horizontal spinner category. As you can see here, those are great against flippers, which we might encounter, lifters, that kind of thing. They're good against thwack bots. They're good against wedges with weapons high up, because we should hit them before we reach the weapon. And they're also good against rammers and that kind of stuff. But the reason we're really choosing it in the 150 gram class is the robots are so small, it's very hard to actually deliver significant amounts of damage. They can bounce all over the arena and be fine. So by picking a full body spinner, we have the maximum moment of inertia. So for a given weight, we can store more energy at a certain RPM. So that's really why we're going with this design, is just to maximize our energy storage, maximize the amount of damage we can do to an opponent, and hopefully that will allow us to actually disable the other robots instead of just throwing them out of the arena like we often see in this weight class. This is a 250-pound robot, so it's good for illustrating how the robot works, and then we'll show you a design that'll be closer to what we're doing, since our robot will be about 750 times smaller than this robot. So you can see here, there are two motors here that drive gearboxes, that drive the wheels. That provides the translational movement of the robot, and to be able to win, you have to show translational movement. So we need a good drivetrain so we can move around effectively and actually move the weapon into the other robot. You can see here that they have a motor with a shaft coming up, and then a belt drive to a large bearing assembly here that supports the shell. Since we're at a much smaller scale, ours will look a lot different, but this is great for illustrating the basics of a full body spinner. Additionally, you can see this translucent part here that surrounds everything is the shell. It mounts here with some large bolts, and then it covers the whole robot, and it also has teeth here for hitting the opposing robots. So as this spins up, it stores this large amount of energy that can be delivered through these teeth into the opposing robot. You'll also note some design details here, some blocks so that the shell can't hit the inner workings of the robot. This is a big titanium shell, I believe, so it can really flex when you hit another robot, or if you're hit by another robot. So to give you a better idea of what we want to do, this is a picture from Matthew Vasquez of Team Fast Electric Robots, and this is one of Ghetto Logic Robotics' Robot's Baby Blaster. This is the new version of it from the 2017 Smashbots event. And you can see here, instead of having the belt drive from the motor to a central axle, the actual motor itself is an outrunner type motor and actually supports the shell itself and provides you that bearing axis in the middle. So this will help us save weight, and it'll also reduce the complexity of the robot and the space and height required. You can also see there's just one drive wheel here. I mean, there are two drive wheels, but one is visible here, but there are no belts or separate power transmission or bearing, so we're just going to support the wheel straight on the motor, and that should be sufficient. We're also going to have more slanted sides like Megabyte here. So instead of the sides being vertical, which can open you up to attack from vertical spinners and take a more direct hit from a horizontal spinner, we're going to go with the slanted design like Megabyte here, where the sides of the robot are slanted. A horizontal spinner will give you a glancing blow, and hopefully a vertical spinner will not even be able to reach you. To give you guys a quick overview of the parts that we'll be utilizing, we're going to start with this Quantum B1806 motor. What's really nice about this motor is that it actually has a 3mm shaft that runs up through the motor. Most of the motors in this size and weight class just have a 2mm shaft, and that's not going to be sufficient for what we want to do with it. So this is a really nice package. It's a little on the heavy side, but since we're combining our motor and our bearing and shaft support, this should be great. You can see with this part bolted on the top, there are screws that go down. There are 4 screws that go into the outrunner shell. What we can do here is we'll mount our own aluminum adapter here that will come out, drop down, and provide a mounting surface for this horizontal piece of the robot there. This will help us get our height down a little bit, and also reduce the moments on this motor, reduce the loads on it. To power that, we need batteries. We're going to use these 150 milliamp batteries, also from Hobby King here. These are a 25-40C, so 25C continuous, 40C rated. I don't know if they'll actually provide that, but they should be sufficient for what we need them to do. We'll put as many of these in series as possible, so we'll run somewhere between 2 and 4S. This motor is rated for 3 to 4S, so that should be fine. If we can't run the full 4S, we'll have to make do with the lower RPM, and that'll be driven by weight. If we have the necessary weight, we'll run 4 cells. If not, we'll run down to 2 cells. To control the motor, we're going to use a King Kong BL Heli 12 amp Opto ESC. I got some of these, got a great deal on them. They're now discontinued, so I picked them up before they were discontinued, and they're just a really budget friendly option. They're fairly light, fairly small. They'll be great to get us going. For the drive wheels, we're going to go with the Sanyo N20 motor. The N20 is a nice gear head. It's all metal gears. It's got a metal support here, and they're relatively small and lightweight. They're 12 millimeters from the top surface here to the bottom, and that'll help keep us low enough and light enough to make our 150 gram target weight. And that's the start of our robot, guys. So please come back, tune in. Next thing we'll be going over is CAD. We'll start CADing this robot up, and hopefully soon you'll see something that looks similar to this, but a 150 gram robot, and you'll get to follow along all the way. Thanks, guys.